it is obviously the hot mixes that we do are fat limes, so they're using non-hydraulic quicklime.
Yeah.
Which is obviously a softer material to a hydraulic lime, just in terms of the nature of the material.
Okay.
You could mix it on site, so you can get quicklime and aggregate and mix it on site yourself. Slightly more involved in that one, it's gonna, it's a little bit into the health and safety and making sure you don't get burnt, and it's
so to do that, you would be sort of a metal bin and a paddle mixer.
You tend to do it.
It would just forced action mixer.
Jam. You need a forced action mixer.
You would do.
Yeah, and you need to do it really. It's getting there. If you're doing it yourself with a hot mix, the quicklime expands dramatically.
Yes.
And then it gets hot.
Yes.
And if it will take all the moisture out of the sand you're using.
Yes.
And if it takes it out too quickly, it'll just jam the machine.
Yeah.
So you tend to get it going.
You've got a water spray, or you've got to that thermal changes, and you've got to spray it.
You need to get it wet enough to almost a little run out. So
but
it'll
not
run
off
out like a big wet kind of.
Do you do courses on that?
We do. I mean, our normal courses are on using the mixed, the hot lime after it's been through that process. Yeah. But we can certainly demonstrate that process. We have done on courses where we've done that.
Excellent.
But you tend to run it out quite hot, and then quite wet, and then you just got to leave it for it to dry out a bit before you can actually dig into it and use it.
Yeah. Because
it'll be far too wet to start with, because you've had to make it wet to run it out of the machine.
Yeah.
So this is what they would have done on site. They would have done massive piles of it, massive, great steaming piles. And
I believe the farmers had a lime kiln, and they would go to the beach, collect the shells, break them up, heat them up over a fire, and then do it exactly like that. Yeah, it gets you a very good. Because not all the material reacts, does it? Not all the calcium carbonate reacts, so you get a nice aggregate and sharp aggregate that way as well. So there's a lot of benefits, but it's controlling it, isn't it?
It is controlling it.
Lots of skill involved.
They would have done it with a big, massive pile. Some of it they would have used hot, and then as it cooled down, they would have used it cold. So it's not that you have to use it hot.
Right.
The issues and the danger of hot mixes is that precise thing. You're not slaking the lime down and maturing it. So you've got the lumps of lime in there potentially.
Right.
So if you've got lumps of lime that haven't reacted, in a mortar, it'd be absolutely fine. So if you're pointing with it or building with it, absolutely fine. In a render or a plaster, you've potentially got little lumps of lime that haven't reacted in your wall.
Right.
And then when they take moisture on, they will actually react within the wall and expand, and they'll kind of like cauliflower and pop all over the wall. So you'll get all these pop marks all over the wall. So it's not a foolproof thing doing a hot mix by any means.
It needs skill and practice.
And if you want to eliminate the risk of that popping, you use a very fine quicklime.
Okay.
So we do an ML90, which is a 90 micron powder.
Yeah.
Now, that's not what they would use.
You've got the health and safety aspect of that fine powder.
Yeah, because it goes everywhere. The guys on the yard that do it all the time, they have to be fully kitted and don't do it on a windy day and all that kind of stuff.
Yeah.
To reduce the health and safety aspect, you can use kibble lime, so the lime that's kind of lump size.
Pellets, 5 mil downwards.
Yeah. So it's a little bit slower to react, and you don't get that thing with the dust and all that kind of thing. But the issue is then you have got potentially lumps.
Thanks for explaining that. That's very good.
So it's you can do it on site, or you can do it from a pre-mixed material. So as I say, all of our plasters and mortars that are pre-mixed are made hot, and then obviously they just cool down.
What it was I was thinking of getting a hot a pan mixer, because I want to put the floor down myself,
Okay.
So do you think it's a good idea to get one of these barrel mixers to do the limecrete? Because that'd do the limecrete, the plaster, and the hot lime, wouldn't it?
Yeah, it would. Yeah, I mean, if you're doing anything with lime putty, then one of those mixers is really good, a forced action mixer.
Because you don't have to put as much water into the material to get it to mix physically. I understand.
If you are using hydraulic lime, then you can just use a normal
whisker.
Yes, use a normal drum mixer. So with floors, obviously use hydraulic lime. You can use normal drum mixers.
Right.
It's just a normal drum mixer. You're probably waiting 15-20 minutes a mix, just because it just knocks itself over.
And again, I'm worried about getting the mix proper. Would you do a course on how to mix the limecrete?
Yeah, we do. Yeah.
You do?
Yeah.
When would that happen in the future?
I think we've got. I'll have to check with Nigel.
Sometime before spring, probably.
Yeah. Yeah, we've got a bit of a floor to do it at Timau. We've got the recycled foam glass down, but we haven't put the slab on it yet. So.
Oh, good. That's good.
But yeah, the key thing is the mixing time. So if you're mixing in a drum mixer, you mix it for 15-20 minutes.
Right.
If you're mixing it in a forced action mixer, it's more like 10 minutes.
10 minutes.
Putting more power into it.
But I don't make any assumptions, because I know it might sound simple just for mixing stuff, but it's getting the batch to batch consistency and the rate at which the water's going in, and the procedure really has to be quite strict. So
that with the floor system, you need, if you get it a nice stiff mix, then you'll speed up the whole process, and you'll get a lot less problems.
Waste and problems.
Because
what can go wrong then, basically, if you put too much water?
If you do it too wet, you get a lot of cracking.
Right, a lot of cracking.
A lot of cracking, and it'll sit there wet for days and days.
And won't cure properly.
Yeah, if you get the right mix, you can walk on it the next day.
Excellent.
So it's that kind of thing that is, way in the past on Grand Designs when they had an issue with it, is because they just had no idea what they were doing. So they mixed it super wet. When it was actually freezing outside.
Worst possible scenario.
They just didn't have a clue what they were doing.
Right.
But, so yeah, straight for the.
So did you manage to have a look at my videos? I mean, I've got them on my iPad if you'd like to.
We can do that, or I can put them on the.
So I excavated 40 centimetres down, and I came to a very thin clay layer, and that was a sample of the soil.
Okay.
And it's pretty damp, really. And I also noticed in the building the exterior ground and the interior floor are at the same level, which is very bad.
Yeah. Can you drop the exterior level? Or
Yeah,
not?
probably will do that.
Yeah. What I would tend to do with flooring, and if there's any sign of damp in flooring, is drop exterior levels where you can.
Yeah.
Put a physical land drain around the building where you can. So that is a trench that you dig, fill with, put a geotextile membrane in.
Right.
A formal land drain pipe, plastic perforated pipe.
Yeah, about 100 mil sort of thing.
Yeah, and then clean drainage gravel, and then wrap the geotextile back over the top.
Right.
And then put more clean drainage gravel over the top of that.
Right.
And then that's a physical drain that, when it rains, is physically taking water away from the base.
I was worried about the foundations of the building. How deep would I go in that, not to upset the building?
Yeah. So in terms of the outside, your external land drain, if you can have it about a metre away from the base of the wall, so you're not at any point undermining the base of the wall.
A metre away.
So it will take the water from that area and this area.
Good idea.
You don't have to dig straight down.
Excellent.
And then on the inside of the building, so for this flooring system to work, this is kind of right to the right scale. But the recycled foam glass layer, for it to work, because this has a wicking break. So if this is sat in water, over a certain depth, it won't physically be able to pull the water all the way up through the material. So this goes in at 120 mil. So you put it in about 150, 160, and then whack it down to 120. Right. So this finishes at 120.
Right. 160 mil. And when you say, is that with respect to the top of the skirting boards, as in, you know, I've got a suspended floor which have all rotted the skirting boards, and you're saying down from the top of the skirting board 160 mil, and then it's compacted to 120. Is that your reference point, the measurement?
So this is your finished floor level. So from here down. So you want to. Yeah. So this ends up at 120 mil.
That's the thickness, 120 mil. Yeah.
And then generally this slab is 100.
Is 100.
So you're looking at 220.
Is that a minimum 100? Is it? Probably. Minimum.
Yeah. I mean, if you were say putting big flagstones down, then you could reduce this to 80 or 75.
Okay, so if I had 3-inch flagstones.
If you're putting small tiles down, you'd keep it at 100 mil.
Right, 100 mil.
But if you got old reclaimed flags, that
exactly.
You won't get any point loading on them.
Point loading. Yeah. Okay.
So
that
generally
is to scale then, is it? That's a really good.
So that's generally 120 mil.
Okay.
And then you obviously got your thickness of whatever floor covering you've got.
Now let's imagine this is the wall and the 24-inch stone wall.
Yeah.
Okay. So where should the ground level be on the immediate?
On the outside
of the stone wall there now.
So on the outside.
Yeah, the outside of the wall. Yeah.
The outside is usually about just at this kind of height.
Relative to that.
Yeah.
About that same height.
Yeah. So it's below the floor level.
Below the limecrete.
Yeah. I mean, if you can't do that, then that's fine.
It's just grass. It's just grass on the outside.
Down a little bit lower.
So it should be about the same. The ground should be about the same level.
Yeah, but obviously, you just got to do a few trial areas just to see what your foundations are like.
Yeah,
if they stop here,
and
obviously you don't want to dig down there, just leave it.
Yeah.
But then put a land drain in down here somewhere.
Yeah. Okay. Okay.
So that's the kind of general build up of the floor. So you've got your geotextile membrane that goes straight onto your soil.
Yeah.
So what you do with your soil when you dig it out, if you just rake that level.
Right.
If you've got any real soft spots in it, just get a bit of hardcore, pop it in the soft spots, and then whack it.
Right.
So you've got a really nice level base.
Got to be flat. Right. Good.
So when you've got a nice level base,
get
a you can hire a laser level.
Yeah.
Set it up at the height that set it up at 120 mil, or basically you'll have two heights: the height that you put the material in at.
Yes.
And then the height that you want to whack it down to.
Yeah.
And that'll just be going around the room.
Yeah. Spinning.
This goes loose fill. So you just barrow this in.
Yeah.
Rake it level as you go.
Yeah.
To the height that you want it at.
Yeah.
And then a whacker plate
over
the top. And it takes quite a few goes. If you just do it once, it won't whack it down.
Right.
You go round and round and round and round.
Yeah.
To the point where you've got 120 mil on your laser level.
Yeah.
And you know then once it's down to that level, it's got its compaction rate. You'll actually hear the vibrating plate. It'll change noise, and you'll feel it hitting the,
Yeah.
as it all compacts.
Yeah.
This won't, a few of these might break up at the top.
Yeah.
But it'll just all hunker down, and you'll get it nice and level.
Okay.
So it obviously won't be smooth because there'll be all holes in it because of the recycled foam glass, but nice and level.
Yeah.
Then you put another geotextile membrane over the top.
Yeah.
And wrap your two sides.
Wrap the sides
back over
the top.
So it's almost like it's all completely contained.
Great.
Are you using underfloor heating or not?
Is it beneficial in terms of getting rid of the damp in the building?
It works extremely well as a method of heating an old building.
Okay.
But it's entirely up to you. If you are going to do it, that's when you put this, which is a geogrid.
Right.
So that's just a rigid plastic
right.
grid. Then you can then use that to cable tie your clip rails onto that.
Right.
And then you can put your pipes in.
Is it pipes or electrical?
This is water pipe.
But is electrical any good or
it is, but electrical you'd be putting here, not down here.
Ah, okay.
because of the response time.
Oh, right.
So with water pipes, you're heating up this slab, and this slab becomes thermal mass.
I see.
It's right on top of your insulation, so
Yes.
you're not getting any loss of heat downwards, because this is all insulated.
It's all going upwards.
This uses a nice dense aggregate, so this conducts the heat really well, so the heat goes up.
And that aggregate is Tymore's special screed, isn't it? Because normally you would use sharp sand, wouldn't you? And that's where I'm a little bit confused. Because one of them is much denser, isn't it? And this is much lighter.
Well, for the slab, we use a nice. If you're using underfloor heating, you use a nice dense material,
like
so you
sharp
get
sand.
good conduction. Yeah. If you didn't have the underfloor heating, then you could use a much lighter weight to give a bit more kind of insulation value.
Yes. And then put the electric ones on top, perhaps, do you think, or not?
If you were going electric, what you would do is you'd put what you'd really want to do is put your slab in, and then put a cork board laid on top of your slab, and then put your electric underfloor heating. It comes as a mat. It rolls out as a mat, almost with a sticky fabric on it, and stick it onto the insulation, and then put a thin screed on top on your tiles. It's just that it's almost touching the underside of your tiles, the electric underfloor heating.
Right. So the response time will be much faster than this, but because it's a lower thermal mass, isn't it?
Yeah. So this.
Which do you think is the best solution, the water or the electric, or not to bother with any?
The electric used to be horrendously expensive to run.
Right.
It's still more expensive to run than this.
Yeah.
So this is still the wet system. Is still more economical.
Right.
It's a slow response time.
Yeah.
So this, you don't have this. You don't just switch this on and off during the day. You have this on constantly during the winter months.
Right.
But it's just on a very low tick over heat, and it just maintains the heat of the slab.
Oh, okay.
So in terms of your heating bills, it works out really well.
Oh, I see.
If you want heating that's is switched off and you just want to switch it on with a quick response time, I mean radiators would be the best rather than floor heating.
Yeah. But that's what you would put on top then, when you put your cables.
Yeah, it's just so it's on top of something that's an insulation, so it's straight on the insulation.
Okay.
Okay. You could get away with that and then just use an insulating aggregate in the slab, like we do a pumice one, but you'll inevitably get some downdrift of heat into this.
Now, if I didn't go for any heating option,
so you just ignore that and you just put a slab in.
Now, would the dampness in the wall take over? Would it all start coming down, or I'm saying is the electric and the heating is it helping to get rid of evaporate the dampness?
It's nothing to do with the damp. No, it's just simply a method of heating.
Overcautious with the damp.
Yeah. So if you do put if you do put underfloor heating in, that's when you put a cork edge insulation against your wall, and that's simply that you don't want to lose the heat from the slab into the wall.
Oh, okay.
Otherwise, it'll just constantly be drawing heat into the wall and won't keep it in the slab.
Yeah, I assume that was to do with the damp in the wall, really.
No,
cork.
simply for underfloor heating.
Right.
So if you don't have underfloor heating, you don't have to have that at all.
Interesting.
So the floor system, this recycled foam glass deals with your moisture vapor and deals with your liquid moisture.
Yeah.
Okay, so if you do get a very high water table, then even if that's sat in water, it won't physically be able to pull the water all the way through that material.
Yeah.
So that's what gets past building regs without having a damp-proof membrane.
Yeah.
Because that's controlling your water.
Yeah, that's clever. Very clever.
Then you get moisture vapor that will transfer up and down in this material. It can go up and down as the seasons change.
Right.
You might get a little bit of moisture vapor coming into the very bottom of this slab. Okay. But first 25, 30 mil, and then it'll go back down. The limecrete will buffer that. You won't get moisture vapor coming all the way up through this slab and out the top.
Oh, okay.
So once the slab is down, obviously you have to wait for the moisture that you've the water you added into it to come out.
Yes.
From the mixing process.
Yes.
Once that's come out and this is bone dry,
yes,
then in theory this should always stay bone dry because your moisture buffering is happening below this top level.
Right.
So that's why people can put ceramic tiles, they can put
Right.
carpets, they can
Right.
put all sorts of things down which aren't breathable on top.
Yeah.
Because as long as the top is dried out before you put anything down on it, you won't be getting water vapour evaporating off the surface.
Okay, that's good.
It's all happening below.
I look at it as a sort of, the U-bend experiment. Then water tries to find its same level, doesn't it? So with the outside, it's quite a high. There's a high hydraulic pressure downwards, isn't there? So it's tending to push upwards, to get the same height, isn't it? It's trying to equalise its height.
Yeah.
So you've got the outside.
So if you can
so it's actually got the equilibrium is going to be that, isn't it? Essentially with this float system.
Yeah.
Where you're telling it to do that really, rather than it, finding a natural.
Yeah,
level.
I mean, on the outside, that's the reason why you're taking the ground levels down. You're putting a land drain in
to take the hydraulic pressure away.
If when you dig the floor completely, or if you find that there is actually water sitting to the point where you've dug down, then all you do is you put a land drain actually inside the room as well.
Okay.
And then you take it out through a doorway and connect it to your outside land drain.
Okay.
So that's what I've done in my own farmhouse kitchen.
Okay.
So when I dug the floor out of the main property, absolutely fine.
Yeah.
When I dug it in the kitchen, it was actually sitting water.
Wow.
So I just put a land drain in, out through the doorway, connected it up.
Okay.
And that's now been in for 5 years. And
you put a gradient on the pipe, sort of.
Yeah.
Was it 1 inch in every foot or so? Is it?
Yes, something like that. I can't remember the full.
Something like that.
But
okay.
It's so it works perfectly well. So any water coming in just gets taken away, and this all stays dry then.
Yeah, that's very good. It's a very nice floor. I like it a lot. It's pretty effective, isn't it? It's proven technology, isn't it?
Yeah, I mean, we've been doing it for 20 years, and we've supplied thousands of them now.
Great.
Thousands and thousands.
So this exterior floor level wants to be about either lower or about the same as that.
Yeah, ideally. I mean, if you can't, then you can't. And if the best thing you can do is get it level with the top of the floor, then that's fine. What you don't want is it to be up here. Yeah. So you're stepping down into the building when you come in from the outside.
Yeah, I think that's very good. I mean, it's the floor really where the damp comes, isn't it? From? I mean, it's so well constructed, the building, that it's the floor really that's the weakness.
And the floor area, and this thing about damp is that it will be where you get damp in a building. It's either from penetrating from rainwater,
cracks,
from top of chimney stacks, and
roof
damages in the roof, and then from water being forced at ground level. It's 99% of the time rising damp doesn't exist. It's water being pushed somewhere. So from external levels being higher, or a concrete slab which isn't permeable, and then water gets concentrated. And
it's the management of it, isn't it?
Exactly.
All right, that's excellent. I'm very happy with that. So thanks for explaining that.
That's all right.
Okay, so
I can look at aggregates for this. I mean, we don't do sea sands just because we don't get involved in that area.
Is it more like a shale aggregate then?
Yeah, I mean, in terms of the colour, it's going to be much closer. It's, the closest that we're going to do is our shale.
Really, isn't it? The Cheshire one, it seems, I guess.
Yeah, so this one is quite green. Can't really tell what it's like.
It doesn't have to be perfect, but something